Part C goes a little bit further now. It's saying discuss the velocity, which is v of t, worked out before, okay, which we worked out to be 100 minus 40 e to the minus t on 5. Okay, it says discuss the velocity of p as t approaches infinity. Okay, what does this mean? So what it's saying is, as t starts from 0 and goes up, starts to become very, very large, what happens? What happens to the velocity? Does the velocity go up? Does the velocity go down? Does it reach 0? What happens to velocity? Okay, so it's effectively asking us, as t goes to infinity, if I can write that, okay, where does velocity go to? Okay, does it increase? Does it decrease? What happens? Okay, so how do we, what's a good way of doing this? I guess the easiest way is to just put some numbers in to see which way this moves. Okay, so you could say, okay, let's see what happens at when t is equal to 1. Okay, let's look at that. v1 is equal to 100 minus 40 e to the 5. Okay, and you'll find a value. Okay, so we just need to work that out. I'll just bring in my calculator. So we just have a look at, so we'll say 100 minus 40, and we need e, 40, there it is, e to the power of minus 1 divided by 5, close bracket, close bracket. Okay, whoops, I've made an error there somewhere. Let's just clear that, go back a bit. I must have missed out a yes, I've put in the wrong minus sign there, unfortunately. Just apologies for that. Minus, let's give this one more go. 40 e, don't want that, go bracket, that's the minus sign I need, divided by 5, close bracket, enter. Comes up with 67.25. okay, so over here we've got 67.25 centimeters per second. Okay, let's adjust I'm just using this to illustrate to see in which direction this moves. So this here became 67.25. okay, what would be good is if we just looked at the behavior of e to the minus t over 5 rather than looking at absolutely everything, okay, to see how does this move. Does this become does t, as t goes up to infinity, does this go up or does this go down? Okay, so let's just look at that on the calculator again, just that particular part of the problem. So I'll make t equal to let's say I'll make t equal to 100. So now we have minus 100 divided by 5. Okay, you can see t has suddenly become a very, very small number, 2.06 by 10 to the minus 9. Let's just try something a little bit to get a slightly bigger number. I'll go back to t equal to 5, say. Okay, again, let's look at that. T equal to 5. So minus 5 divided by 5. You can guess why it chose 5. Okay, gives us a nice minus number there, minus 1. Okay, the number is 0.36. okay, so a smaller number again. Okay, so what we can conclude from here is that as t goes up, okay, so from here we can say that as t is approaching infinity, v or this part of the function decreases, it goes down. Okay, and as t becomes very, very large, this value here, okay, this particular value here will approach 0. So we can say as t approaches infinity, e to the minus t on 5 will approach 0. Okay, so in the limit where t is equal to infinity, okay, this will be equal to 0. So if this is equal to 0, this part of the of the expression will be equal to 0. So in that case, v as t approaches infinity, oops, that's a very dodgy infinity. Okay, again that's even worse. Let's try just doing that. Okay, now it's tempting to just make the substitution and put infinity in there. Okay, I don't really like that. It's really as t approaches infinity. We're not plugging in infinity for t, because we're looking at as t approaches infinity. I think that's a cleaner way of doing it. Okay, v as t approaches infinity is equal to 100, because this part approaches 0. Okay, so v is 100 centimeters per second as t approaches infinity. Okay, so we now know, as you start making t very, very large, okay, the velocity of this particle p, okay, will start getting closer and closer to 100. If t could ever reach infinity, which it never will, okay, the velocity will be equal to 100. We can't really talk of it as it ever reaching 100, because t will never reach infinity. Okay, and as you'll see when we sketch the graph, to see what it does. Okay.